In this video, we will be seeing how to do the offline programming in MPE software. For that, you need to open the software, MPE software. After you open the software, the below screen will be displayed. In this screen, you have to click on the projects. On the projects, you can see new, open, close. These are the menus which will be accessing for creating a new project offline mode. So let us start the programming in offline mode. For that, you have to know what is the controller name and what is the controller model number. For that, click on new, or you can go to file and click on new project. Once you click on new project, you need to create one destination for your projects to be saved. So I'll create a new project and click on enter. Then we have this series, controller series. So I am using 2000 series. And what is the model number in which I am going to do the basic offline programming. So here we can find different models available, in which we are going to select MP2300S series, and I need to give a name for the project for developing offline. So I'll start with trials and click on create. Now you can see the project has been created. Here you can see offline, you can see what is the controller name and where is the project path available. So it is available in D projects, where we created one folder, and what is the name and what is the extension. Extension is YMW7. Why 7? Because this is version 7. If you are using version 6, you will not be able to see the 7 digit. It will be .ymw. So now we will start the basic programming for MPE software offline. For that, I need to know some basic module configuration. What are the hardware available in the project? For that, I need to go to module configuration first, and I have to click on save. Once I click on save, whatever was highlighted in the green color has become black. So that means this has been saved in the project file. So now the basic thing we'll do is basic thing on communication settings. How many access are there, and based on those access we will try to do some basic programming. So I'll double click on the option available for communication. So I'll double click on this. So it is asking me to create a new file. I'll click OK, and you can see the basic IP address is 192.168.1.1. So this is my controller IP address. So in case if customer or some third party wants to change this address, you can change this to any number you want. Then after that, you have to click on save. And if there are multiple controllers you are going to communicate, but you need to know what is the controller name, you can name the controller name as whatever based on your application. I'll select cutting. So and save. So now your controller name will be defined as cutting machine. So this is the status of the controller, whether it is communicating or not. Once we go online only, we will be able to check what is the status. But now I showed this for your equipment name has been changed over here. Now I will click on save and close this, and next I need to save to project. So next time when I download this project, it will be named in cutting machine. Next we'll try to integrate one axis. In that one axis we'll try to do the basic operation and basic programming. So I will take one SVB axis and one SVR axis. So we'll go with SVB. So in my previous video you might have seen how many cycle time you can define. So now I am going to define only 3 axes. For that I will change the axis configuration. So now it is 8 axes. I will change to 3 axes. And this is sigma win. Whether you want to used or not used, you can keep it not used and close this. Then you need to save the project. So now you can see this is a scan cycle of 0.5 millisecond. For every axis the scan time is 0.5 millisecond. So now I will define one axis. I'll right click here and device select. I'll click on servo. I'll take sigma 7. I'll use Mechatrolling 2 module rotary axis and click on OK. So now I have added SGD7S to my module configuration and click on save project. So now if I define the drive, so I need to define what is the unit for it. For that I will double click on this icon and go to fix parameters. So fix parameters will be defined only once. So I can use this normal mode operation, and there are different modes. So I can select what is the reference unit. So reference unit will be in mm and how many decimal points I need to select. This depends upon the user, how much accuracy you need and what is the circumference of one rotation. Say if the diameter, I'll just quickly go to, and what will be my circumference is nothing but multiply this into your pi value. So I'll get 157.07. So this is the value you are going to enter in the option 157.07 and apply OK. The same value I will be entering here also, 157.07, apply OK. Now there is no gear motor or gear ratio, so we will leave this 1:1. That means if I give 157 pulses mm, so it will go to one rotation of my axis. After that we will do everything default and save. Right, one save is done here and we need to do the other saving to be done here. Okay, now I will minimize this and go to SPR and define one axis. I will right click here, device select, rotary axis, OK. Then I will save to project. I will double click here and go to fix parameters. OK. So now you can see what is the difference between a virtual axis and a main axis. Most of the options for virtual axis will be disabled. So you need to check what are the options available here. Click on OK. Then what is the option you want to do it in, virtual access, reference unit, what are the number of decimal points, those things we can all change. So I'll change this to 157.07 and I'll keep all the basic thing common, save, OK. Then I'll go to here, save. So now we have defined one virtual access, one real access in offline mode, but you need to know what is the difference, how to use. You can say the circuit number 1 and 2. So circuit number 1 is for SVB. In the circuit number 1, you are using access 1. And for virtual access, there is circuit number 2 and you will be using access 1. So this is how you differentiate between the two access. Now I'll save and I go to the software where we'll be doing the basic configuration. And here you can see this is the variable menu. So this menu is available. If it is not available, you can go to view and you can check variables. So you'll get this variable options. So presently you click on access. So once I click on access, these are the values available. In this you can see circuit 1, access 1, circuit 2, access 1. So these are two different access. This is main access and this is virtual access. For our interface, I'll keep this as V1 and click OK. So now you can see there are two access available. If these two access are not available, you just click on refresh once so that this will refresh and you will get the access. And how to use the other option of IOs. In the IOs, we will go to module configuration. So this is 2300S. S means single slot. So I have one single slot available here. I'll right click here and device select and I will go to module configuration, IO models. What are the model which is there in my hardware or project? I'll click on this option LIO01 and click OK and save to flash. So now I have saved the parameters. So now I'll go to here and click to save option. So now the project is also saved, but I have to check whether my IOs are available or not. So I'll click on this, I'll check. These are the two IOs which are available. Local IOs, 16 input output and one counter. So what we'll do is we'll try to do the basic programming and explain what are the basic address required for doing the programming. So here you can see access 1, access 2. So you will have 80 words. So totally 80 words will be available in between one access and the other access. So for virtual access also you will have 80 words. But all 80 words will not be able to access in the offline programming. So now we'll try to go and do the basic programming, how to create a ladder. For creating a ladder, you need to click on create new ladder, or there are some iScans available here. So this is the basic ladder programming. In the ladder programming, you can use either high scan or low scan. So high scan, we may have given some values for 1 millisecond, and for low scan it will scan for 200 milliseconds as default, but sometimes we'll keep it as 50 milliseconds. So for any high scan, you right click here and click new. So it will show H iScan and a main program. So if you want to change the title of the program, you can change the title of the program based on your application requirement. You can define, and you can also see the number of D registers available here. So number of D registers can be used inside the program. H main program will be around 32 numbers. You can either increase this. Okay. Now I have created a iScan program. In the iScan program, I can write some basic high-speed scanning programs where I will be able to do my basic functions and how to call a iScan program. For that, I have to create one more child program. So H program is nothing but your master program. In the master program, you need to create one child program. That means H01. H01 will be my access configure. Click on OK. So now I have made one main program and one subprogram. This subprogram will be called through main program. For calling this main program, you have to right click here and insert, and there is a function called SEE. So click on it, enter, and you have to click on this question mark drop down list. You will find what is the subroutine to be called. So here you can see I have already created one H101. So after that it will be called directly. For making this project save, you need to compile. You click on F4 to compile. So now you can see there are no alarms or errors available over here, warnings and errors available over here. So if there are any warnings are available, we need to debug on the warnings and alarm. Now we'll see how to do the basic configuration for the drive. So this is the drive access configure. So now what we'll do is we'll try to insert a rung. For any servo on condition, we need to do the basic thing is to check for condition. So what is the first main condition is that there should be no alarm. That means I need to use the words which are available for access 1 is the alarm. Alarm is a word. So if this word is equal to 0 and there is no warning, you Control C, Control V, then I can make servo on. For inserting, you can press F7. Okay, so and this is the first bit. I'll flip, right? So now you can see I will compile and I'll save this. So now the project is saved offline. So you can see if there is no alarm or warning, your servo will be on. So this is the first condition. The same condition you can write for virtual access also. This is my main access. I can differentiate by using insert command. I'll write svb access and press Ctrl Enter. I can right click, insert. I can copy this. I can paste this. I can right click, insert command, SVR access, Control Enter. So I need to change the name only by double click on it, and we know that it is V1, and here also it is V1. So now we come to know that this is only basic settings for servo on. I'll compile and save. Now that we have done the basic setting of servo on, depends upon your inputs and outputs, you can do the basic configuration for the access. Now we have seen how to do the basic configuration of servo on. If you have any interlocks regarding how to make the servo on, you can add any of the interlocks over here. It can be a physical inputs or any memory bit you want to use, you can use. So how to use a physical input, I'll show. So you have to know what is the input address you are going to use. For that you have to click on, if it is a NO contact or NC contact, you can add from here. So if you press F5, it will be NO contact. If you press F6, it's going to be a NC contact. And there is one more shortcut for, if you press A, it will be a NO contact, and if you reverse B, it will be a NC contact. So I'll take A and enter, and I need to define the name for this. So I can just drag and drop here. So this is the input number 0, which I will be using for making it servo on. I can use it anywhere here. You can just drag and drop. The same input I can also copy here and paste here, Ctrl C, Ctrl V. Then I can click on compile. Then I can click on save. So I can also rename this input. I'll double click on this. I can change this command to servo on, enter. So by doing on this, you can know that when this input servo on is high and there are no alarms, there are no warnings, then your servo will be activated. So here also you can see we can change this, which we have not done. So we'll make it to V1 and compile. So now I have made it servo on, and I made one input also on, and whether we want to know whether the servo is on or not as a feedback. So what we'll try to do is we'll try to insert one more ring and check whether servo is on or not. So based on the input feedback, we'll make one output on. For that I am going to use one output over here. So I'll make this as servo on out, and for better understanding I'll make it servo on in. So this is my input and this is my output. So based on this I can also make the same thing, same changes over here also. Or what I can do is I can take one more output. For my virtual access, I will Ctrl C and click here, Ctrl V. I'll change this to V1 and I'll change this to output 1. So this output 1 will be my virtual access output. Virtual servo on out to differentiate. So I'll save yes, because this is in offline mode. You can use Ctrl S. Then you can also compile. Yes, now it is compiled. Now click on save. So now the program is saved. So now we have done only the servo on. So how to clear alarm? If there is any alarm in the system, how to clear the alarm? For clearing alarm, what we'll do is we'll try to insert a rung try to insert a comment, alarm clear, control enter. We'll try to use one physical input. I'll try to use this input A, control C, control V, then alarm reset. If any alarm is, we need to press this input, then there is a coil for access 1 alarm clear. So we need to clear this. Once this input is high, and we can clear this alarm, but before that alarm should be generated. So how to find out whether the alarm is generated or not? For that, you right click here, insert a rung, and we need to write a condition to check whether alarm is created or not. So alarm conditions we need to know. Alarm occurred. So if an alarm is occurred only, you will be able to clear an alarm. For that, you need to know whether the warning is greater than 0. That what is the alarm? Should be greater than 0, or in parallel the warning, either one of these are active. So we'll set a bit. For that we'll get MB0. So MB0 is my first bit of my controller. So I can use this bit. Once the bit is high only, I'll be able to reset the alarm. So what we'll do is, we will copy, paste, and we'll give the tag servo alarm occurred. So once servo alarm has occurred, you press this reset, servo drive will reset the alarm. The same way you can write the alarm for virtual access also. So here you can change to V1. Here also you can change to V1. If it is greater than, I'll take a different variable as 1. So I'll try to tag this reset. Sorry, it should be occurred. So what I'll try to do is, I'll control C, control V, and you can also do it parallelly, or you can take a different rung also. If you want to do it parallelly, you can delete this and you can merge this with this, and you can copy this, and by dragging through your ladder logic, you will be able to do this. You can do this way also by using only one input. By using only one rung, you can do this also by changing this to V1. So when this input has come, either one of the alarm has occurred, you can reset the corresponding access. So now I will compile and save. So now what are we have seen? We have seen access on, that is servo on, then alarm has occurred and we have cleared the alarm.